He's going to talk about licensing, and he's going to tell you the do's and don'ts and make it really, really simple for you guys. I have one quick introduction that I want to do, and then I've got an announcement, and then we'll get started. So, hey, Joe, come on down here. So if you guys haven't met Joe, he's like our unofficial launch code library liaison. I mean, every week he's here making sure stuff happens. Yeah. Every week he's back there doing the AV, and so, guys, this is Joe Schwartz. If you haven't talked to him, actually, so Joe's a local St. Louis author, and his book today on Amazon just hit 800,000.
No, it's ranked overall the 849th most popular book on Amazon today. So.
Right.
It's fleeting glory, I promise.
What's the name of it?
A Season Without Rain. And looks like
What's it about, Joe?
it's a
Baseball.
yeah, that's what it's about. It's about a guy who's struggling with the question of the meaning of life and trying to decide if he wants to continue and go further, or if he wants to simply end his life. It's very light, very there's lots of clowns and balloon animals are involved in this. So,
but ranked number 5 in family fiction overall.
It's in the St. Louis Public Library, so get a card and check me out. Literally. Thank you, Mike.
Hey, thank you, Joe. Thank you, guys.
Pleasure having you guys.
Joe. Thank you. Okay, so we had some requests last time. We worked really hard over the weekend to try and get you guys exactly what you wanted. Today we'd like to officially debut what we're calling Launch Code TV. Essentially, we're taking all the mini lectures, all the videos that we've ever created, putting them up on a site that's simple, concise, and easy for you guys to get to. We've got about 20 videos up there right now. You can walk through anything from Java to Linux, working with the command line. In fact, we even have it set up so it's in a series, so you can start with the easy ones and work your way down to the hard ones. So this is, and I know I'm gonna have to. Yeah,
Reverse proxy.
really? Be a good talk. And we even have a video on how to upload your own video to Launch Code TV. That way, if you guys do something that's awesome, you want to tell other people about it, you can put it up here yourself, because really this is all just a GitHub repository. And let me pull it up real quick.
You should just use GitHub Pages.
Well, I'm just using S3 and Travis.
Then you don't have to pay for it, and you can use a custom domain.
That's true. That's
You
true.
just gotta pay for the domain, that's it.
Nice. You guys show me that. All right, but yeah, just give me a pull request on Launch Code TV, and you guys can have your very own videos up there. So, without further ado, let me introduce Keegan. You guys know him pretty well. He's going to tell you guys everything you need to know about licenses. He's not a lawyer, but he can give you some pretty good insight on the do's, the don'ts, and generally just make it easy on you guys. No one's going to sue you, really, so don't have too hard of a conscience on yourself. But guys, Keegan.
Hey, alright. So, licensing. Very, very interesting topic. I promise you. So, I'm not a lawyer. I don't pretend to be a lawyer. This is not legal advice. I'm really not a lawyer. So, don't sue me. Thanks. So, a few licenses you'll run into. So the best ones that you can deal with are MIT or BSD or Apache. I think artistic licenses falls into this. You don't have to worry about anything. It's free for commercial use. You can modify, rename, distribute, sub-license, whatever. You just can't say that they endorse you. You can't say, you could maybe say powered by jQuery, but you can't say, official jQuery project or anything like that. You also don't have patent rights on their stuff. I think you do in Apache, but probably don't even need to worry about that. So now we have the LGPL, which is the lesser general public license. You can't statically link it. That means if it's really a questionable thing what it means. So I tend to avoid it. But basically it means if somebody really wanted to, they have to be able to replace easily the library with another version or something that provides the same functionality. And then you must tell whoever's using your product or whoever you sell the source code to, you either have to give them the source code to what you're using or give them a way to get to the source code of what you're using. And then now we have the AGPL and the GPL. So it's similar to the free ones, the first ones I talked about, but you must distribute your source code, especially if you are selling your product in some form, you have to distribute the source code. And then you cannot take something licensed under the GPL and then relicense it as something else. And this is actually used by like Red Hat. They're like the big dog in the Linux world. And you can't get like Red Hat on a CD unless you pay for it. But you can get all the source code and go through a bunch of work and build it yourself, which is a really weird situation, but it's not worth the effort to build it yourself. Then we have the WTF-PL. I'll let you imagine what that means. And the public domain. You can do anything you want with these. It literally belongs to everyone equally. So generally, if you're not making money, you can get away with a lot. They might ask you to stop. They might say, hey, you have to credit us somehow or whatever. But that's typically the worst that'll happen if you're not making money. If you want private source code, typically just avoid the GPL. If you earn money and something is licensed one way for open source and can be paid for, you'll probably end up having to pay for it. This goes for some popular things like Isotope for like dynamically resizing columns and stuff. You have to pay for it if you're going to make money. If you have specific concerns, ask someone with a law degree. I am not one of those people. Finally, if you're open source, just use MIT or BSD. Those are the simplest, best licenses for everyone. Talk to a lawyer before you're selling it or the source code. And then there's this awesome website called tldrlegal.com where you can look up, say, the MIT license. It'll say what you can do. You can use it for commercial use, modify, distribute, yada yada. Cannot hold them liable. And you must include the copyright and license. It makes it really simple for some of the weird licenses out there. Again, this is not legal advice because people don't like being sued. I'm still not a lawyer. Thank you.
Questions for Keegan?
Yeah, questions. I can answer some of them, maybe. Any specific yes?
Concerning Apache, particularly, I know that's a pretty popular one, at least one that I've seen when I go to different sites, so on and so forth. So, would you recommend that over MIT? Is there big difference?
There are some nuances. I don't specifically remember them, but they're very comparable. So I just like the MIT and BSD because they're very simple. They basically say, you can't use my name, and I think some of them don't even say that. And basically, you can't hold me or the people who wrote this liable for any damage done to you through using this thing that I gave to you for free, basically. And that's basically what all of them exist for. And then the more specific ones to protect your code or to protect, like GPL is meant to protect open source and force people to use GPL, basically. So, yeah. Anything else? Yes?
Yeah, practically speaking, I guess after listening to you, I'm thinking, I don't think I need to spend any time worrying about it for the final project. It's, you know, it's only if somebody wants to do something with it after the final project that I ought to focus on licensing issues.
Basically, that's what it comes down to. If you want to do something more with your final project, if the final project is a springboard onto something else, or if you're even thinking that you might, at least have an eye towards that so that you don't specifically choose to use something that will later down the line kind of mess you up. But until then, don't worry about it. That's my advice. Yes?
I would add that you have the right to keep your code proprietary until such a point that you can release it under an open source license.
Yes.
For example, Microsoft recently open sourced their compiler for their .NET stuff. So they've open sourced that, but it took years and years and years for them to even decide to do that. So if you want to have like several versions of your program be proprietary and only later figure out exactly what license you use, that's a strategy a lot of people use.
Yes, but you still run into sometimes if you're using some things, you have to open source it and stuff.
Exactly.
Yeah, exactly. And also, I must say that Microsoft's effort is an empty gesture without the underlying CLR.
Yeah.
Anything else?
Yeah, I would just throw out for the final project thing though, if you're turning it in for our Harvard class, you need to be concerned about the honesty policy.
Right.
They're not gonna be real happy if you're using a license that you shouldn't be using.
I guess, but I mean, if I were grading someone's final project, I mean, unless it was something horrible, like using an illegal version of it, basically, like you should have paid for this sort of thing. I mean, I wouldn't care.
Well, I mean, if you're doing anything like even writing a paper, you have to quote everything and where all your sources, where you got things, and I'm sure that they're looking at licensing stuff as well.
I doubt it, but
We will ask them.
yes, that is a good question for them because I can't speak for them. But really, all the licensing stuff is a lot of trouble. Anything else? One more. Yeah.
One more, okay. Since if you put anything on GitHub, it's very visible. Pretty much
Unless
open
you
to anybody
pay
else.
for a private account, yes.
That's correct. So is there a default license on GitHub? That is, if you don't explicitly license it some other terms, what terms does it fall under?
There is no default license under GitHub. They actually, when you create a repository, they prompt you to add a license,
Okay,
which you probably should.
which you don't, what's the default?
That's a very legal
What's the default
gray
one pick
area.
if you just click through?
I mean,
None.
none, yeah.
None, and so none
And
license
so
would
I could
apply,
theoretically just assume that's open, that's
which,
public domain.
public domain. So
Theoretically.
anybody can take your code and run with it then.
Possibly, yeah. I would avoid
Not
doing that then.
possibly. If
Yeah,
you
yeah.
don't pick a license, it is
Yeah, I
public
mean,
domain.
yeah, I'm not gonna, because that's a question for a lawyer. I really couldn't say specifically, but quite possibly, they could just take it and run with it. Thank you.
Alright, so tonight I'm talking to you guys about RESTful databases. I mean RESTful URLs. And we're going to touch on a couple of different things. We're gonna have to walk into database land for a little bit to give you guys a big idea of what's going on. But this is a talk that I repurposed from a YouTube group, so it's a little broad, but bear with me, it's got a lot of good stuff in it. The original title of this talk was Databases That Don't Suck. Speaking of like no SQL. So we're going to be featuring CouchDB and Nginx. Oh yeah. Alright, so who is this guy? Anybody know? Larry Ellison? He's an asshole. He's like, I don't suck. Relational databases, they hold the vast majority of the entire world's data. And you know, it's a technology that's been proven out for over 30 years. It's mathematically proven to work. And he makes a lot of damn money doing it. I mean, a lot of damn money. For example, that's his car, right? It's chrome. That's his boat. This is real stuff. This is his boat. Here is his fighter plane. The San Jose airport actually stays open late so he can come over and fly his fighter plane. And here's his house. You notice the little tram that goes down to the pool? I mean, this guy is ridiculous. Finally, you know how there are 8 islands in Hawaii? Like, it's a state, there are 8 islands in this state. He owns that one. I am serious. This guy is filthy rich. Filthy rich. And, by the way, he also bought Java 2 years ago, too. So, what a jerk, right? It was open source beauty, and now it's closed source evil. But here's his friends. He hangs out with Microsoft, he hangs out with Oracle, IBM. These are the buddies that he hangs out with. But you know, Oracle, you really do suck. Because in the end, Oracle is all about having one single machine hold all of your data. One giant mainframe. And they use it at Monsanto, and they have one giant machine at Monsanto. And it gives them a lot of trouble. But that's not how modern databases work. You guys know how Google works, right? They take commodity-grade machines, like machines you'd find in your basement from like 5 years ago, and they network them all together, and they make them work as one machine in the cloud. And you know, that's how Amazon does it. That's how Twitter does it. This is the way of the future. And so with Oracle, you've got rock-solid data. It is always going to be correct. It's always going to be up to date. It's never going to be stale. But with the new, it's going to be slow. The new approach says, hey, we're going to play with this thing called the CAP theorem. How many people have heard about the CAP theorem? Did they mention it in CS50? No. Okay. The CAP theorem states that a database has 3 properties. It can be consistent, available, and partitionable. Consistent means you can always get to your... consistent means that the data is always the same across, no matter where you look at it. Available means that you can always get to it, and partitionable means you can put it on different machines. So the new way plays with Oracle. They're saying, hey, I want this to be really consistent, I want it to be really available, but partitionable, not so much. And sorry, Keith, I'm stealing along your talk. It's
not available unless that machine is available.
Yeah, exactly. So NoSQL comes along and says, hey, we're going to mix this up a little bit. We're going to make it, instead of it being consistent and available all the time, maybe we're going to make it partitionable and consistent. Or maybe we'll make it available and partitionable. And so it's just changing. It changes the way you do databases. It changes the way you look at databases, and therefore it should change the way you structure your data in your web app. So even if we don't have gobs and gobs of data like Twitter, Amazon, and Google, we can still use this concept to make it easier for us to program. So let me give you guys an example of like 95% of the corporate jobs out there that I have worked. They might be different, but the ones I've seen so far, here's how it works. All right, you go to the database, you get the data from the database, turn the data into Java objects, then you turn the data into XML or JSON to send to the website. There are billions of lines, trillions of lines of code that does this, guys. It's not dry because they completely repeat themselves multiple times within an application, across multiple applications. So, because really when we think about it, databases, their only purpose for a database is to simplify and remove data. I mean, you might think they're this big magical thing, but really they're not. Let's talk about how these things, databases work, what their true purpose is, okay? Because we could have a CSV file and call it a database, MyDB. That could be my database. All right, so let's take a basic listing of classes. You know, we've got CS 101. The name of the course, Fundamentals of CS, is taught by Dr. Bailey, and Sally's student is going to be taking the class, right? So now we've got an entire class of students. We've got Sally, we've got a different student, we've got some other student, and they're all taking the CS 101 with Dr. Bailey. And we multiply this by 1 million. What a database does is it says, well, the problem with that, just having a list of data, is what if Dr. Dare switches with Dr. Bailey? Now we've got Dr. Bailey's name duplicated all across this data. We have to go in and change every single record. So what a database does that makes it really simple is they say, what if we have 2 lists? Instead of having just one list, we're going to have two lists, and we're going to have a key associated with the one list. So in our first list, we're just going to have a list of all the classes, and it's just going to have the class name, the description, and who's teaching it. And then we're going to have a key, a unique key that identifies that class. And in another list, we're going to have that unique key for that class and the student name. And then we can do what's called a join. How many people have written a join so far? Yes. Yes. You need joins. This is essential stuff. And so with a database, they say, let's join these two together. We're going to have two separate lists. I'm going to write some code. So I'm just going to go through, and whenever I find class 1, I'm going to replace it with Sally's student. And we're going to replace it with a different student. So now we can generate that data without having a really big redundant list. We can have two separate lists. And so here is another example. And students can even be in multiple classes. But essentially what it comes down to is, when you've got this data in the table, there are only 4 things you can do with it. You can only create the data, right? Insert, you can only read, which is a select, update, or delete. There's only 4 things you can do with this data. And they're all represented within the basic SQL commands, right? Because you've got select, insert, update, and delete. Those are the 4 commands you can do in SQL, right? So let me introduce you to this guy. Getting on to the REST part. Now you guys know databases. Now you know where they come from. Now you know how they were derived. Let me introduce you to an all-American badass. This guy's name is Roy Fielding. Why exactly is he a badass? Well, let me tell you. He was the principal author of HTTP. I mean, this is the backbone of what every single website works on out there. He created the Apache web server, the world's most popular web server. It's the one you guys have been working with this entire time. He created that. And he had some thoughts of his own on how data should be structured. He didn't really think it should be structured in the traditional database way. He says, well, if we're working on the internet, and most lines of code are just trying to get the data from the database out to the internet, well, wouldn't it make sense then for every piece of data to have its own unique URL? And so for courses, you've got http://truman.edu/courses, which would give you a list of the courses, and then CS101, and that'd be the unique key for the course. So every piece of data has its own URL. And he said, well, HTTP, we've got 4 methods. You know how SQL has 4 methods? Create, insert, read, select, delete, update. HTTP has create, post, put, and delete, right? And now most of the time when you're working in your browser, most of the time it's just doing gets. Most of the time it's just doing gets. Every now and then you'll do a post. CS50, did they talk much about doing posts and gets?
Yeah.
Yes.
Yeah, nice. In my early PHP vernacular, I was just familiar with gets and posts, and puts, they were just kind of strange because it seemed like they did the same thing as posts. True Rastafarians do these. All right, so what Roy Fielding thought should happen is, hey, so let's, just like a database, let's have a create method. And so if you do HTTP post to this URL at courses and you send it some JSON, some data, we can add a new record to our database. And we can do the same thing with get. We can say, database says select we HTTP has a get. And if we do a get on this URL, we can get the contents for CS360. And the same can be true with an edit. Put. You can use a put to update that data on that URL. And if you want to get rid of that data, you just simply say a delete at that URL. And so you're working with the same, every piece of data has the same URL, and you've got 4 methods that work with it. Input, delete, read, and update. Now this kind of solves the problem, right? The classic database problem that, MySQL, Oracle, IBM, These databases are all purposed to get data to the internet, to get data to the real world. But they didn't really, we had to write Java code to do it before, and they didn't really have a clear way of doing it. The RESTful web is the universal database. You've got all these nouns that you can work with in the RESTful web, and there are no verbs in the RESTful web because you only have 4 verbs. You can only create, post, update, and delete. And so with the RESTful web, every piece of data has its own URL. You can only do 4 things with it, and that's it. And then machines can actually understand this web because the machine can just find any URL endpoint and say, hey, if I need to get data from here, I automatically know how to work with it. You know, when you're making your URLs for your PHP application, it's probably pretty tempting to make a URL that's like send or submit or add user, right? But adding those type of URLs, they're different for every application, and you can't swap them out really. You're adding verbs into what should be just a RESTful environment. And so the RESTful web is this universal database that machines can understand. So let's see what's next. Oh yeah, you guys saw this. This is an actual song that was released on the WWE Originals soundtrack with Rey Mysterio, Chris Rock. This is a real song. This is just my way of breaking up the monotony of talking about databases and then talking about just a little bit more. So let me reload it real quick. All right, so you guys know the principles of REST a little bit. I want to show you guys a database that is completely RESTful. In fact, it doesn't require any special drivers to be installed. It doesn't require any special, oh, come on, Shockwave. So for example, like on your web page, you would serve up different types of data. You know, you serve up human readable data and you serve up machine readable data. Human readable data are your .html files. Machine readable data is your JSON and XML files. And so if you want to get human readable data, you end your URL with .html, right? If you want to get machine readable data, you end it with .json. And is anybody writing a JavaScript app? Nice, nice. Has anybody ran into the CORS error? Cross-origin resource sharing? But essentially, if you want to bring all these pieces together, if you want to have a RESTful database, a RESTful environment that you can work out of, you're going to run into this thing called CORS. And CORS is a security feature implemented on all of your browsers. And when I first ran into this...
It doesn't make it any more secure.
Yeah. When I first ran into this, it gave me a lot of trouble, so I want to tell you guys about it so you can know about it right away. But anyway, what it says is you can only get data from one domain. So if I'm getting my data from localhost 8010, I can't get data from localhost 8011, right? Because that's insecure. Because, you know, somebody could inject some code into your site and they could load up their own data into your website and then your data would be compromised. And so really, the key to being able to have a good website is using a front-end server that is able to direct all your traffic. So if I want to have 3 servers in the background, I've got a server on 8010, 8011, 8012, then we can use something called Nginx or Varnish.js to direct the traffic where each one's supposed to go. Okay, so here's what I'm talking about with Nginx. So you can see, all right, I've got Nginx running on port 8009, and now any URL that comes in on /chats, I'm going to send to localhost 5984, which is my CouchDB database, and that's my RESTful URL. I'm serving up all of my HTTP, like all my HTML from a different server, and then I'm serving up Socket.io, which gives you real-time push-to-the-browser capabilities, and that's running on port 8003. And so it lets me bring all of these things together and bypass the CORS error that you would normally get. And so, yeah, that's a really good question. So the question was, what do you have to do to get a database, get a website up and going that uses an API? Because you've got your front end built out, right?
Right.
And you just want to use APIs, and do you have to have a back end in order to use those APIs? Is that what you're thinking?
Well, mine is going to be a situation where we're going to have multiple people hitting data at the same
Yeah.
time, so I definitely want a database behind it of some kind.
Yeah, absolutely. And so, yeah, that's one of those situations where, yeah, you wouldn't be able to make a direct call to those APIs because of the core's requirement. You'd have to put it behind this proxy server like Nginx. And you can just start up any type of server you want behind that proxy server. You can start up like a Node.js server, or a PHP, or even Java if you wanted to. And it would make the calls to the API, get the data, and then send it across the wire. But my hope and my goal is that we can spare you guys some crucial hours and give you a little head start if we give you this little tidbit. Even if I didn't get to show it to you, now at least you kind of know, hey, I need a proxy server in case if I'm going to do something that has multiple databases on the back end. And so, yeah, so hopefully, yeah, we can just give you the little tips. And if you have any questions, shoot them towards Zach at LaunchCode, info@launchcode.com, or Brendan, and we can answer them. And we'll hopefully or post them on Reddit, even better. Post them on Reddit, and we can get back to you guys. And so you guys don't have to spend a lot of time researching questions that you don't even know how to ask. So, all right. Hey, thank you guys for listening. I know this was kind of a dry talk, but I appreciate you paying attention the whole time and being really good people. So, yeah, thank you guys.